Hi, my name is Noelle Germain, and I'm a postdoctoral research fellow working in the lab of Dr. Stormy Chamberlain at UConn Health. I am very excited and truly honored to be the 2017 recipient of the Angelman Syndrome Foundation Wagstaff Fellowship. I want to thank the Scientific Advisory Committee and the entire Angelman Syndrome community for supporting my work. With the support of this fellowship, my goal is to test the efficacy of two novel approaches for reactivating paternal UBE3A in our human-induced pluripotent stem cell model system of Angelman syndrome. Previous work from labs including Dr. Art Baudet, Ben Philpott, and Mark Zilka have shown the ability to reactivate the paternal copy of UBE3A using antisense oligonucleotides and topoisomerase inhibitors that work to reduce the levels of the UBE3A antisense transcript. Building on these exciting findings, we feel that it's important to pursue additional approaches for reactivating UBE3A in Angelman syndrome neurons. In order to help you understand our approach, I'd like to first use an analogy to explain how we believe paternal UBE3A is silenced in Angelman syndrome neurons. If you can imagine two trains heading towards each other on the same track. One of these trains represents the UBE3A antisense transcript, and the other train represents UBE3A sense. As these trains head towards each other, eventually a collision is going to occur, and because the UBE3A antisense train is bigger and stronger, it will derail the UBE3A sense train and no UBE3A protein is made. So if you can imagine then that we can develop ways to derail the antisense train before it collides with UBE3A, we may be able to develop novel ways to increase UBE3A protein. With the support of this fellowship, I will test our hypothesis that other means of cutting the UBE3A antisense RNA, such as ribozymes and short hairpin RNAs, will similarly derail the antisense train and allow activation of paternal UBE3A. The other approach I plan to investigate is to use cutting-edge CRISPR technology to test the hypothesis that we can directly increase paternal UBE3A by boosting its production. This is akin to replacing the UBE3A sense train with a more powerful high-speed train that allows it to outcompete the UBE3A antisense train and allow UBE3A protein to be made. I'm very excited to be able to pursue this work under the guidance of Dr. Chamberlain, and I hope that our work will help in the advancement of therapeutics for Angelman syndrome. Once again, I want to thank the entire Angelman syndrome community for your support in our work.
Noelle's work builds on that of giants such as Drs. Ben Philpott and Art Baudet, who found that they could reactivate Dad's copy of UBE3A by stopping the antisense transcript. This work fits with the ASF's mission to continue to search for new therapeutic approaches for Angelman syndrome until everyone with the disorder has the best quality of life they possibly can. I'm incredibly proud of Noelle for earning this fellowship and carrying on this work. I'm grateful to the Angelman Syndrome Foundation for helping us to keep a talented researcher such as Noelle in the Angelman Syndrome community.